All right, so today we're talking about arithmetic and geometric sequences. So these are just specific types of sequences versus just general ones. So first of all, an arithmetic sequence begins with a fixed number, and then you repeatedly add a constant. So like you start with 1 and you add 2, add 2, add 2, add 2. You start with like 3 and you add 4, add 4, add 4. So you start with one number and you just keep adding the same thing over and over again. That thing you're adding is called the common difference, and we represent it with a D. So here's some arithmetic sequences. Take a second and try and figure out what is the common difference for each of these. Okay, so you can just take the first one and subtract the one before it, or take this one and subtract the one before it, and you should get a common difference of 4 for this one. Here, if you subtract, you should get a common difference of -1, and this one a common difference of 12. All right, so then how do we actually write out these sequences? So this one is the last one from the last page. We're going to do this recursively. Start with your first term. Always, always, always write down your first term. So 112 was the first term. And then we're taking that first term and adding 12 to it. And then we're adding 12 to it. And then we're adding 12 to it. So you're always adding 12 to the term before. So the term before u sub n would be u sub n minus 1. And then you want to add 12. So that's your recursive formula. So if we look at this for an arithmetic sequence, beginning at your A, your first term, going on forever, this first term, you have A, and you don't add any common differences to it. The next one, you add one common difference, 2 of them, 3 of them, etc., 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 etc. If you notice a pattern, this is the first term, you have 1 common difference. Third term, 2 common difference. Fourth term, 3 common difference. So if we rewrite a general formula, you're going to have your first term, or your A, plus 1 less than the term you're at, times the common difference. And then this is the formula you can use to write your explicit formulas. So if we want to define this sequence explicitly, your common difference is still 12. Your first term is 112. So your A sub n is going to be 112 plus n minus 1 times 12. Now simplify this. So you have 112 plus 12n minus 12, and you'll end up with 12n plus 100 is your explicit formula. So for arithmetic, putting it all together into one nice simple slide. Here it is. Recursively, define it like this. Make sure you always write down your first term as well as the formula. And then explicitly, you follow this formula. You can write it with the curly brackets, or you could write it like this. It doesn't really matter, or I don't really have a preference which one you do. All right, why are they called arithmetic sequences versus something else? It comes from the idea of an arithmetic mean. So arithmetic mean, you add up all the terms, divide by the number you have. It's just like the regular mean we've done before. So you have 5 terms, add them all together, divide by 5. But here, if you have a sequence, if it's an arithmetic sequence, if I want to find this term, I can add the terms on either side and end up getting that term. It's the average of the other terms. So then here, if I wanted to like add 2 on each side, divide by 4, you should still get 13. All right, next type. Geometric sequences still begin with a fixed number, but then you are multiplying by something over and over again instead of adding. So arithmetic, you're like adding 4, adding 4, adding 4. Geometric, you'd be like multiplying by 2, multiplying by 2, multiplying by 2. What you're multiplying by is called the common ratio, and represent it with an R. So these sequences, go through and figure out what your common ratio would be. All right, this first one you're multiplying by 2. Second one you're multiplying by -3. And this last one you're multiplying by a half. So yes, you are dividing by 2, but the common ratio is always multiplying, so you want to rewrite that as multiplying by whatever the fraction is. Defining recursively. So common ratio here is 3. This is our first term. So always list your first term, and then we want to figure out how to write this next chunk. So if you think of here, this is your second term. To find the second term, you have to use the first term, and then we're going to multiply it by our common ratio. So you end up getting u to the n minus 1 times 3 versus adding 3. We go through the same process that we did for arithmetic. If we start off with our first term here, we're not multiplying by any common ratios. To get to the second term, you need 1 common ratio, 2 common ratios for the third term, 3 for the fourth term, etc. So if we write this out in a general form, you want the first term times 1 less than your number of terms common ratios. So then if we were going to define the sequence explicitly, you take your first term, so 2 times r to the n minus 1, and then replace your r. So here, in this case, the r is 3. And that would be your explicit formula. Y, similar idea. Oh, sorry, put it all together first. Here's everything all in one. Again, you can write this as a to the n equals, if you like that, or rather than the curly brackets. Okay, let's skip that. So why are they called a geometric sequence? Same idea. This comes from a geometric mean. So geometric mean, instead of adding them up, dividing, you're multiplying everything and then taking the nth root. So if you have 4 terms, you'd multiply everything together, take the 4th root. And the same idea here. If you take the 2 terms on either side, take the square root, take the 4 terms on either side, take the 4th root, you should get that value. All right, so here's another sequence. What is it? This is the Fibonacci sequence. If it will start writing. Fibonacci. Anyways, there's the spelling. So look at this. Is it arithmetic? And then try to decide, is it geometric? Which of those is it? As I rewrite Fibonacci. So it's not arithmetic because you're not adding the same thing. And it's not geometric because you're not multiplying by the same thing. So the thing about this is not all sequences are arithmetic or geometric. Those are just different subsets of your overall total sequences. For your homework, check on Schoology because it might be a little different than this. But that's it.